Hello everyone. In this video we will learn how to graph exponential and logarithmic functions. And we are going to start with an exponential function. Okay, so in this case here, 2 to the power of negative x plus 1 minus 1. In order to draw an exponential or logarithm, we need to follow these steps. So step number 1, we need to find the y-intercept. We need to find the x-intercept. You need to have horizontal asymptote or vertical asymptote. Now for any exponential, we will have a horizontal asymptote, that's for exponential. Vertical for a logarithmic function. And then we need to tell what is a domain. And finally, the range. Okay, so these are our 5 steps. So let's start with the first one. We need to find y-intercept. Y-intercept. Well, y-intercept is basically f0, which is equal to the power of negative 0 plus 1 minus 1, and that's equal to 1. So I'm going to go here and try to find 1. That's y-intercept. Step number 2, you need to find x-intercept. And to find x-intercept, we need to make this equation equal to 0. So now I'm going to say 2 to the power of negative x plus 1 minus 1 equal to 0. I'm going to move the 1 here. So 2 to the power of negative x plus 1 equal to 1. Now I don't have a common pace, but I know that 2 to the power of 0 is 1. 3 to the power of 0 is 1. 5 to the power of 0 is 1. Which one I'm going to use? Whatever pace I have here. If this is 2, then I'm going to use 2 to the power of 0. If this is a 3, then I'm going to use 3 to the power of 0, okay? So that's what we are going to do. So, or you can use length for both sides. It's up to you. But this is easier. So it would be 2 to the power of negative x plus 1 equal 1. 2 to the power of negative x plus 1 equal 2 to the power of 0. Since you have the same pace, so negative x plus 1 equal to 0. Negative x equal negative 1 and x equal 1. So my x-intercept is also 1. Okay. Now next we need to find the horizontal asymptote. Now again, for any logarithms, any exponential function, we have a horizontal asymptote. So step number 3, we'll find horizontal asymptote at. Well, for a horizontal asymptote, it's a horizontal line. And any horizontal line has an equation y equal k. What is k in this equation? Well, the equation can be written in a form t by using the transformations b x minus h plus k. This number can be 2, can be e, can be 3, whatever pace. It does not matter what is the pace. So k is here. By looking here, this is k. Okay? So now k is basically negative 1. So I'm going to say it has a horizontal asymptote at y equal negative 1. So I'm going to go here and draw a horizontal asymptote at y equal negative 1. Now we can match. So you can match now between these 2 points. And since there's a horizontal asymptote, the only way you can match between these 2 points and go closer to the horizontal asymptote is by doing this. Okay, that's your, of course there's an arrow here. That's your graph. And that's the only way you can basically match and go closer to the asymptote. Now you need to tell the domain. So by looking here, the domain is all real numbers from negative infinity to infinity, right? But what about the range? Well, the range starts from the asymptote all the way up. So the range is basically from negative 1 to infinity, open from both sides, because at negative 1, it's an asymptote. Okay, that's how we draw an exponential function. Let's try the next question. We are going to follow the same steps. Okay, so in this question here, 8 minus 2 to the power of 1 minus 2x. Okay, so first of all, y-intercept, which is f0, 8 minus 2 to the power of 1 minus 2 times 0, and you substitute, and the answer is 6. So you go here, and that's your y-intercept. Now, step number 2, x-intercept is basically when the equation equal to 0. So 8 minus 2 to the power of 1 minus 2x equal to 0. Move the 8, negative 8. Now, since I have negative and negative, I can multiply everything by negative 1, so I can, or divide by negative 1. That's going to make this 2 to the power of 1 minus 2x equal 8. 8 can be written as 2 to the power of 3. So 2 to the power of 1 minus 2x equal 2 to the power of 3. Since I have the same pace, so 1 minus 2x equal 3. Negative 2x equal 3 minus 1. And now negative 2x equal 2, and x equal negative 1. So you go at negative 1, and that's your x-intercept. Now, we need to find the asymptote. So, for the asymptote, we will have a horizontal asymptote at y equal k. So, let's find out the horizontal asymptote. Where is k? So, I do have horizontal asymptote at y equal k. Now, where's k? Well, looking at this function, I can rewrite it as negative 2, 1 minus 2x plus 8, instead of having 8 at the beginning. That's going to be your k. So, I can say at y equal 8. So, what you are going to do here? You will go to the 8 and draw a horizontal asymptote. And now it's time to match. Well, you need to match between the negative 1 or 0 and 6, 0 and 0, 6 and the asymptote. So the only way to go with that is, so I'm going to just try to go here and go closer to the asymptote, but never pass by it. So now domain, as I mentioned before, it's going to be all real numbers, but the range in this case will be from negative infinity all the way to the asymptote. So it's like this way. But then since negative infinity is smaller, it goes first to the asymptote and open. Okay, moving on to this question here. We're going to again follow the same steps. So step number 1, y-intercept, which is f0. That's going to be 3 plus 4 to the power of 0 minus 1. That's going to be equal to 3.25. So you kind of go to 3 1/4 here, maybe somewhere here, and that's going to be your y-intercept. Step number 2, we need to find the x-intercepts now, or intercept. I'm going to make the equation equal to 0. Move the 3. Now this is an error. Even if you try to take length for both sides, this is an error, okay? So that's going to be an error. So error. So what does that mean? No x-intercepts. There's no x-intercepts, okay? So I do have only one point, which is the y-intercept. Now we will find the horizontal asymptote, which is y equal k. So step number 3, horizontal asymptote at y equal 3. y3, it's here. This is k. Now I will go to y equal 3 and draw a asymptote. Now, by looking at this graph, well, I have two ways of matching. I can match this way, or I can match that way. which one is right? Well, in order to decide, we need to have another point. And I'm going to take any point. So let's take any point here. Anything you want, anything. I'm going to take 1. Okay, so I'm going to substitute by 1. So I'm going to take this, I'm going to add this step. And the reason why I add it, because I don't have an X-intercept. I need to know which direction I'm going to match it. Do I match this way or this way? Okay, so the only way to do that is by choosing any other point and substituting X by that number. I'm choosing 1. 3 plus 4 to the power of 1 minus 1. 4 to the power of 0 is 1. 3 plus 1 is 4. So 1 and 4. Now I know that I'm going to match this way, okay? So I will match now. Of course, you can make it longer and extend your graph. So now domain is all real numbers. And the range, as you can see here, from the asymptote all the way up. So from 3 to infinity. Now in this question, I'm going to follow the same steps, but this time the pace is E. And it's going to be the same. So Y-intercept, which is basically F0. E to the power of negative 0 plus 2 plus 1. That's about to 8.4, kind of, 8.4. You can use the calculator for that. 8.4 somewhere here. Okay. Now we need to find step number 2, X-intercept. And if I want to find X-intercept, I'm going to make the equation equal to 0. Now again, this is an error because it cannot be negative, and if you take len for both sides, you will get len negative 1. That's an error, so no X-intercepts again. So there's no X-intercept. So I know the function is going to be this way or this way, kind of. Or maybe a bit down. We'll see where is my asymptote. So now let's move on to the asymptote. Oh, okay, let me return the point here back. So I have a horizontal asymptote at y equal k. K in this case is 1. So, okay, so it's here. Now I need to match. It's either, again, I'm going to match this way or that way. How do we decide that? We need to take another extra point. And you can take, in this case, anything you want. I'm going to take 2. The reason why I took 2, because I want to make this 0. That's all. You can take anything else. E to the power of negative 2 plus 2 plus 1, that's going to be 2. So 2 and 2. 2 and 2, which is going to be here. Now, how you are going to match, it's going to be this way then. So I'm going to match now. And we're going to go all the way from here. Okay, and here we go. Now you can fix it. You can make it better. For me, it's a bit hard here. Kind of. Not really good, but anyway. So domain, as I mentioned before, is going to be all real numbers. And the range from the asymptote, which is 1, to infinity. It goes up, right? So that's everything about graphing exponential. Now we will move on to graphing logarithmic functions, okay? So we are going to move on now to the logarithmic functions. And again, we are going to follow the same steps. So let's look at this question here, which is 1 minus log 4 minus 2x. And as I mentioned, we are going to do the same. So y-intercept, which is basically f0, 1 minus log 4 minus 2 times 0. And by putting this in the calculator, you are going to get about 0.4. Okay, so 0.4 somewhere here. Okay, you can just a bit fix it, kind of. Then you will take an X-intercept. That's by making the equation equal to 0. Now move the 1 to the other side. So negative log 4 minus 2x equal negative 1. Now you can multiply everything by negative 1 to rid out of the negative from both sides. So log 4 minus 2x equal to 1. And now you write it as an exponential. So the base here is 10. So 4 minus 2x equal 10 to the power of 1. Negative 2x equal 10 minus 4. Negative 2x equal 6. And x equal negative 3. So that's going to be my X-intercept. Now it's time to find the what? The asymptote. Now we're doing, remember, exponential function and logarithmic functions are inverse functions. So we know that we are going to have a horizontal asymptote at exponential. Now what about a logarithmic? Well, it will be vertical asymptote this time. So in this case here, step number 3, I'm going to have a vertical asymptote at x equal h. And I need to find h here. Well, if you look at the function, it's going to be log b x minus h plus k. Remember, that's going to be your h. So we need to reorganize this function. So let's do it in the side here. It's going to be negative 2x plus 4. Now we will take negative 2, which is b, as a common factor. Remember the transformations. That's going to be your h. You change the sign. So in this case, h is going to be equal to 2. And it's a vertical. So you go here and draw a vertical asymptote. Now we will match between these points. Let me just fix this one here. Okay. And now we match between them, and in order to match you need to go closer to the asymptote and then cross. Okay, domain and range will be the opposite of the exponential because they are reciprocal they are inverse functions, right? So now domain in the exponential, the domain was all real numbers. Here the range will be all real numbers. In the exponential, the range was from the asymptote to infinity or the negative infinity to the asymptote. Here it's going to be from, again, it's going to be the domain. So in this case, the domain will be from negative infinity all the way to 2, which is the asymptote. So we are following the same steps. Y-intercept. Which is f0. And that's basically about negative 1.96. Then X-intercept, which is when you make the equation equal to 0 and you solve it. Now I need to rid out of the 3. I will divide both sides by 3. I'm going to add log. Then you write it as an exponential 3 to the power of 0. That means x plus 2 equal 3 to the power of 0 is 1. So then x equal 1 minus 2, which is negative 1. So you go, let me find out these points here. Negative 1, x equal negative 1 here. Now, y-intercept, negative 1.96, which is about negative 2, but a bit before negative 2, okay? Now we need to tell the vertical asymptote. Vertical asymptote. A vertical asymptote is at x equal h. h in this case, not 2, it's negative 2. because remember, we have done this before, you change the sign of k. So a negative 2 is going to be here. You go here and you draw an asymptote. And then you match between these points, this one and this one here, okay? So we match, we can go closer to the asymptote, and here we go. Now, domain is going to be from the asymptote, which is negative 2, to infinity, where the range, as you can see, the range is filling everything here, so all real numbers. So let's do this one. So first step, Y-intercept. So F0. And that's going to be equal to negative 3. Step number 2, X-intercept. That's when you make the function equal to 0. Equal to 0. And then you solve it. So I'm going to move the negative 9. Then you can divide both sides by 3. And then you write it as an exponential, which is going to be 2x plus 4 equal 2 to the power of 3. Finishing it here. I'm going to finish it here. So 2x equal 2 to the power of 3 is 8. And then move the 4 to the other side. 2x equal 4 and x equal 2. So now by doing this, we know that y-intercept is negative 3. X-intercept is 2. It's time now to find the what? The vertical asymptote. And again, I'm mentioning this. Vertical asymptote because it's a logarithmic function. So, vertical asymptote at x equal h. Now, where's h? You need to take 2 as a common factor in order to tell what's h. H is negative 2. So, you go vertical asymptote at x equal negative 2 and you match between them. Here we go. So my domain is going to be from the asymptote all the way to infinity. Range is going to be all real numbers. Now in this question here, we're going to follow the same steps. So finding the y-intercept, and that's when f0 equal to 2 minus ln 0 plus 1, and that's going to be equal to 2. Okay, and 2 is here. Okay, now next we're going to find what x-intercept. And x-intercept when the equation, the function equal to 0. So negative ln x plus 1 equal 0 minus 2 is negative 2. You multiply everything by negative 1 to rid out of the negative. And write it as an exponential, so x plus 1 equal e to the power of 2, x equal e to the power of 2 minus 1, and that's basically about 6.4. Okay, 6.4. Now we go 6.4 is here. And now it's time to tell what is a vertical asymptote, domain, and range. So for a vertical asymptote, it will be vertical asymptote at x equal h, and h in this case negative 1. So you got negative 1 and draw an asymptote. Okay, now you match between these points, so you're going to go something like that. Okay, domain is from the asymptote to infinity, and range will be all real numbers. So guys, that's everything about graphing exponential and logarithmic functions. Please practice. Let me know if you have any question, and see you in next video. Bye.